G'day, my name's Aaron Wood. I was fortunate enough last year to win Environmentalist of the Year, but I'm also a country boy and it breaks my heart to travel through rural Australia at the moment and see the devastating effects of the drought. We hear the doom and gloom every day. Well, here's some good news. We're going to learn about how to do more with less, about how economics and the environment are one and the same. And to take us on this journey, I'd like to introduce Bruce Chalmers. Bruce, what can we expect on this journey?
Well, today, Aaron, we're going to go through some procedures that we've been using on our own vineyards for 6 or 7 years that can be incorporated into anybody's viticultural procedures economically and very easily.
Sounds great. Well, let's do what everyone's been waiting for and get out into the vineyard and take a look at what this looks like in a practical sense.
At Chalmers Vineyards in recent years, we've spent a great deal of effort honing our techniques in producing commercial crops of high quality fruit with less water. Our focus has been on sustainability and efficiency, and this has put us in a really good situation to deal with the low water allocations due to the persistent drought. The overall result of the combination of techniques we use is that we manage our vineyard on considerably less water than the regional average, while still maintaining commercial crop loads and achieving high quality. Water efficiency is a key. Our water efficiency is achieved by a combination of the following practices: pre-planting amelioration with addition of nutrient and organic composted cow manure, mounding, good irrigation design, control and monitoring, good weed control, reduced soil compaction, balanced nutrition, a commitment to build organic carbon in the soil, and a no tillage policy.
According to Jeremy Giddings, Irrigation Officer of the New South Wales Department of Agriculture in Barunga, the standard amount of water applied in one growing season to irrigated vineyards in the Murray-Darling Basin is 6 to 9 megalitres per hectare, an average of 7.5 megalitres per hectare. The combination of techniques Chalmers employ in their vineyard enables water usage to be reduced to around half of that average. In recent years, Chalmers have targeted and achieved production figures of approximately 24 tonnes of fruit per hectare with little assistance from rainfall. When you add rainfall figures to irrigation water use, total rainfall equivalent for season 2006-2007 at the Chalmers vineyard was just 478 millimetres.
Any rain received during the growing season can be a huge benefit, and you should definitely look at reducing irrigation accordingly, depending on how much rain you get through that season.
The optimum situation is to set up your vineyard sustainably from the beginning. This is obviously not a solution for most growers because the task at hand is to maintain existing plantings. However, it is useful to know the way Chalmers Vineyard has been established, as it helps to understand the way it is now maintained. The soil preparation begins with 25 cubic metres per hectare of certified organic composted cow manure and 1,000 kilograms per hectare of superphosphate plus zinc, which are applied to the bare earth in a concentrated 1 metre wide band along the vine row lines using GPS guided spreaders. Soil amelioration is performed with a vibrosoiler, a vibrating wing ripper reaching depths of 800 to 900 mil. The vibrating wing action incorporates the manure to make an eventual concentration equivalent to 75 cubic metres per hectare, as it's all placed directly in the root zone. The vibrosoiler ripper creates 5 times the worked soil volume of a standard ripper combined with the mounder in the same pass. It scrapes about 2 inches of organic topsoil from the centre of the rows, pouring the carbon-rich soil mix consisting of the pre-spread manure, nutrient and topsoil down behind the tine. This creates a uniform, fertile root zone for the vine to be planted into. The organic matter retains soil porosity and stores valuable moisture at depth, resulting in greater uniformity and consistency in the growth of the vineyard. The creation of a mound which runs along the vine row has been a very successful technique in this and other Australian vineyards. The mound can be formed at the time of vineyard establishment, but can also be simply and effectively applied to established vineyards by retro-mounding. The mounding operation brings vine prunings and leaf matter from the centre of the row onto the 250 mil high by 1,000 mil wide mound, increasing the concentration of organic carbon and topsoil in the undervine area and creating a highly fertile and deeper friable zone for the vine roots. Ideally, a V-shaped mound is created, capturing all irrigation where it is needed over the root zone. The V-shape also reduces mound erosion and captures any rainfall, leaching out any salt buildup in the root zone.
Now, this is an area of the vineyard that's had drippers on it for 4 years now. It was originally overhead irrigated. It's had drippers for 4 years, and we've been retro-mounting it for 2 years. And we're just going to show you the concentration of roots in the under the dripper line, which is where all our nutrient is applied. There's an enormous amount of feeder roots down here.
The important thing to consider during vineyard establishment when aiming for optimum water efficiency is drought tolerance. There are a number of readily available rootstocks for grafting which are tolerant to dry conditions. There are also many vinifera varieties which are naturally drought tolerant if you prefer not to plant grafted vines. Commonly known rootstocks which show tolerance and even thrive in drought conditions are 140 Regeri, 110 Richter, 1103 Paulson, Ramsey, and as for vinifera, there are thousands of known varieties worldwide. Varieties which are native to Mediterranean Europe in the warmer regions like southern Italy and central Spain perform well in hot, dry conditions. Generally, any varieties that are very vigorous on their own roots will do well with heat and less water. Of the varieties more traditionally cultivated for wine in Australia, Grenache, Shiraz, and Cabernet have typically proven more drought tolerant.
Soil management in both new and existing vineyards, we've got both here, is extremely important. You must have a good balance of moisture, nutrients, and we believe, and many others do, plenty of organic carbon. All of these are easily incorporated into your management system for an existing vineyard. There's no infrastructure changes required. Different mindset perhaps to the way you approach things. It's not a difficult thing to do at all, and we just have to keep remembering back to the fact that the soil is the heart of your vineyard.
Organic carbon levels in the soil are topped up annually by the application of between 10 and 20 cubic metres per hectare of organic, composted cow manure deposited directly under the vine row on the top of the mound. There are also 3 applications per year of liquid humic acid applied by fertigation through drippers to increase the availability of nutrients in the soil to the plants.
Most of our gross nutrients are supplied by the cow manure that we apply post-harvest. The cow manure is applied in April and May in time to be leached into the mounds by any autumn rain we receive.
Other nutrients are applied as required by fertigation and foliar application. SAP and PTOL analysis data helps to determine how much and when. Maintenance of the undervine mound is very important and is carried out yearly immediately after manure is applied in April-May. Soil is aerated using a simple rolling aerator immediately before and after annual mounding.
The policy of no tillage on the vineyard floor means that we maintain the integrity of the soil structure. The vineyard floor in our vineyards is only maintained by aeration and mounding.
Irrigation systems and techniques are the central issue to address when looking at water efficiency in the vineyard. In many cases, dramatically reducing water requirements involves infrastructure upgrades. This does require added investment, but reaps many benefits. There are also numerous ways to improve water management which can be independent of infrastructure upgrades. At Chalmers Vineyards, all older plantings have been converted from overheads to drippers, and all recent plantings have been installed with drippers, so that not a drop more water than required is used, while maintaining desired yield and quality. Working closely with your irrigation system design team is critical to ensure you get the best tailored solution for your specific needs. Any new or upgraded systems should be designed to achieve maximum efficiency and to complete water applications at the most appropriate times. This will both reduce evaporation and utilise off-peak power rates.
One of the major factors with our low water use, we believe, is our ability to water all at night. We've designed the system to irrigate only at night or the low periods of low evaporation. I believe we're saving about 20% of our water by that method.
It is important to recognise that in vineyards with existing overheads, generous pumping capacity is already built in. When a vineyard is converted from overheads to drip irrigation, the bulk of the infrastructure is kept. This means that the extra capacity originally installed for overheads can be utilised to irrigate larger shifts of drippers in a shorter period of time. For example, 3 shifts of overheads can usually be turned into 1 shift of drippers. This means less labour for changing irrigation shifts and the ability to complete the irrigation during lower evaporation periods. To achieve maximum efficiency, the absolute best system to employ is drip irrigation. The dripper line is laid directly on the ground along the vine row, which is a more cost-effective installation method than underground or wire-strung dripper lines. It is fitted with pressure-compensating emitters to make sure that the same volume of water is coming out of every single application point, regardless of the pressure in the dripper tube. These emitters are also anti-siphon. They don't suck in air or dirt as the dripper line drains, so no blockages will occur even if the line is covered by mulch, manure, or mounded topsoil. Another advantage of having the line above ground is that if there is a problem, it is simple to detect and fix. There are a number of other methods used at Chalmers to carefully watch consumption and make maintaining the irrigation system simple and efficient, such as magnetic flow meters on all mains. Capacity for recycling of backwash. System design for maintenance simplicity, and flexible, user-friendly irrigation controllers. Regular and accurate monitoring of your irrigation water usage and vineyard conditions are critical to ensure you are giving the vines not a drop too much or too little water. There are many methods which can be used, from high-tech to very basic.
We monitor our water use by a combination of a number of methods. Capacitance probes, or commonly known as C probes, to measure soil moisture in all different soil types. They report by telemetry to a central station every 15 minutes. That 15 minutes is an average of 3 5-minute readings. Flow meters, which are mag flow meters, can be visually or remotely monitored to watch for unexpected flow variations. A weather station which records temperature, evapotranspiration and wind speeds and wind direction. Any grower can just as easily access this information without having their own weather station. They can get that information from the Bureau of Meteorology or via the website. Actually getting out in the vineyard with a shovel and a dig stick and having a good look at the soil moisture profile on a very regular basis. Listen to the vines and look at the vines. Get out in the vineyard and closely watch the shoot and tip growth, tendril growth and other signs such as colour and hydration of the leaves.
Chalmers application rates have now been standardised for new plantings at 0.89mm per hour, delivered by 1.6 litre per hour dripper line at 600mm emitter spacing. Established retrofitted vineyards in the range of 3 to 15 years old are receiving 1.1 to 1.3 millimetres per hour. The regime at Chalmers usually sees 10 to 12 mil irrigation applied in midwinter if the soil profile is dry. The regular irrigations then start in early spring, building from a small amount, say 2 by 2 hour irrigations per week, and gradually increasing as required until the period of maximum use. For example, from November to harvest, when irrigation occurs on a daily basis, up to 4 hours per day, dependent on temperatures. Irrigation is reduced gradually post-harvest.
It's important to consider in our low water use that one of the main reasons for this is that we're actually not trying to irrigate the inter-row area. These rows are 2.5 metres, most of our rows are 3, but these ones particularly are 2.5. But we're actually only watering an area of about 1 metre wide and about 6 to 7, maybe 800 millimetres deep. So basically, if you consider it as hydroponically grown, almost like growing a grapevine in a pot, all our roots are concentrated in that zone, all our nutrition goes into that zone, and that's where we originally ameliorated to 800 millimetres deep.
The root zone only covers about 1/3 of the vineyard floor. So when applying irrigation per hectare, what the plant actually receives is about 3 times that, concentrated directly in the root zone, while the other 2/3 of the vineyard floor, the intervine area remains dry. This is one of the critical factors to understanding the dramatic water use reductions being achieved at Chalmers Vineyard. Maintenance is extremely important and must be carried out regularly. Apart from getting you out amongst the vineyard to see what's going on, maintenance is critical to ensure correct operation of the system and optimum distribution uniformity.
As with any well-designed setup, the design parameters should be for about a 95% distribution uniformity over the whole vineyard. We believe we're getting better than that. Most importantly, on the whole 650 hectares, we have a less than 1% variation in the flow. This is absolutely critical, having these very good figures for efficient water use.
It seems such a simple point, but it's important to consider. Capturing every drop of rainfall is critical in order to reduce your irrigation requirements. Utilising captured rainfall to lightly dampen the mid-row area can also reduce the wicking effect, which can drain moisture from the vine row.
Rainfall capture on our vineyard we're in a very dry area is extremely important, and the small amount of rain we get during the harvest and up to harvest can be captured, and probably the most beneficial rains immediately after harvest. We always spike it, and that aerates the soil and catches the rain.
Soil aeration is very low cost and prevents runoff in the rows during normal to heavy rain events. It is simple to carry out and only needs to be done a maximum of 3 times a year. The overall low cost and ease of implementation makes aeration a good alternative to conventional tillage, which is more expensive to carry out and can be harmful to the soil structure. Comprehensive eradication of weeds is crucial in order to save water. Not one drop should be wasted on growing weeds. 4 to 5 paraquat diquat applications through the growing season are applied by custom-made 3-row computerized weedicide units for efficiency and low soil compaction.
Reducing soil compaction in the vineyard allows for water to be absorbed more readily into the soil. It also allows increased microbial activity.
Chalmers have achieved a major reduction in compaction by implementing a number of practices to reduce traffic in the vineyard. All tractors used at Chalmers have been narrowed to less than 1700 millimetres outside to outside to assure that the mounds are never compacted. Whenever possible, multi-row equipment is utilised to reduce the number of passes made by tractors in the vineyard. Foliar application of any required nutrient happens simultaneously with scheduled fungicide applications. This once again reduces the number of tractor passes required over the growing season. All nutrients, apart from manure and foliar sprays, are efficiently delivered by fertigation, which requires no tractor pass at all. Bin trailers used during harvest are a major cause of soil compaction in vineyards. Traditional chariot-style trailers spread the weight over only 2 tyres, and because the tyres are outside the bin, they are rolling in the undervine area, which erodes the mound and compacts the root zone. To combat this effect, Chalmers designed narrower trailers with wheels mounted under the trailer to self-track for easy operation. Because they are 4-wheeled, they have reduced weight per tyre on the ground by 40%. These bin trailers can be used in tandem and up to 3 at a time to also reduce labour requirements and tractor passes.
I guess when you combine all of the things we've done, it does make a lot of sense. And I think, well, I'm absolutely certain that if everybody has a go at this in different forms, even if they only take on one of the techniques, it will benefit them. But if you use a combination of all of the techniques, which are what we've talked about before, no tillage, mounding, can't emphasise enough how important it is to increase your organic carbon in the soil. That's probably singly the most important reason we can get away with less water. It's also extremely important that you don't think that you have to irrigate the centre of the row. We've gone away from irrigating the centre of the row, pushing enough water out with the drippers to get to the middle of the row. That's absolutely not necessary. We've proven that over years. Look, there's obviously going to be extra techniques in the future. I'm not sure that they're going to have the monumental leaps in savings that we've achieved to date with the basic things. But there will be achievements in the future, possibly with chemical water spreaders, maybe one thing that we haven't trialled yet, but I think there's probably some merit with that as well. But I hope at the end of all of this that if we've been able to help in a very small way with the use of your own personal use of water, but we're talking about a national resource here. If that national resource can be utilised better, I think the whole country's going to benefit. If your business is more sustainable, it's more profitable, and we're all going to stay in business a lot longer. We know we're going to be paying more for water in future. I don't think water will ever be treated the same as it was in the past. It is a scarce resource, and the more efficient use of that, the longer we're all going to stay in business.
I hope this DVD has given you some great tips about how to economically incorporate environmental sustainability into your farm. This is about the future, this is about Australia as an innovative country, and about guaranteeing a sustainable future for every Australian. After all, a healthy environment means a healthy bottom line.